It's actually a better description than what I titled the presentation. This presentation is a little bit unusual for me because it's not actually my presentation, it's Kathy Nishida's presentation. She's the wildlife program manager for the Pueblo. So I was not associated with this project that she did, but I felt it was important enough to present it to you all so that you could see it. And I'm hoping that you'll want to talk about it later, not necessarily now, but that you'll be able to see what we have, and I'll be able to show it to you in more detail later. If there are mistakes, they're mine, they're not Kathy's. And I have basically a list of comments that she's approved. So you're getting the Kathy Nishida approved presentation. So Kathy at one point became concerned that we were doing a lot of restoration and we weren't really sure what we were doing as it related to the bird population. So the objectives of the project was to start to monitor these parameters in the areas that she was monitoring so that we could see if we were on track. And this will make more sense in just a bit. There were 4 sites that we were looking at. So we were looking at high use areas by flycatchers, and these are again migratory, they're not breeding pairs. So high use, non-use, active restorations, so that's where we come in and we're doing vegetation maintenance, and then passive restoration, where, can you not hear me? Can everyone hear me? Yeah, okay. The passive restoration sites are, we did something like bank lowering or river bar lowering, but we didn't come in and do either herbicide applications or we weren't putting in plants. So we let it vegetate naturally. This is, we'll come back to this too. So this is a willow swale that was put in early 2000s. The last one that we put in was in 2010, 2009, 2010. So they're very specific as to what they are. And I point that out now because I'll talk about it in a second. This is an active restoration. So we were involved in all aspects of this. This is our passive restoration site. This is a confluence of the Jemez over here and the Rio Grande over here. And this is kind of that area that was the high use flycatcher area. These are some of the locations up and down if you know part of our area of the river. Most of you don't, but this is the Jemez here. This is the Rio Grande. This is the confluence of the Jemez. This is a west bank of the Rio Grande, sort of over near the Hyatt. So these were the locations that she was collecting data, and she did it for 3 years. And she put in a bunch of hobos. So there were 5 hobos in each site. So she was collecting vegetation data and these environmental parameters. Let me just make sure that I got all the comments right. Every 2 weeks, from May to August, she did this 3 years. So we had at each of those 4 location types, there was about 20 data points, of which for each data point, there was 5 of those hobos put in. So these are all the things that Kathy was collecting data on. There's more here than I have time for. So like stem density came up. We have stem density for all of these. I don't have the results. They just were not important at that, at this time. So this is some of the results that she was finding. So you'll see that high use, and this is a theme that plays out through a lot of this. High use and passive restoration sites tend to look a lot alike. This is vegetation on the bottom. This is the percentage of that vegetation. And you'll see our active restoration site is way different than all the others. But the non-use site, this has come up in past presentations. This willow component is pretty minor, whereas everything else is pretty consistent throughout. So one of the things that she wanted to point out, it came up in other presentations, I was surprised to hear it so many times. Non-use areas were more evenly mixed between native species and exotics with a high salt cedar component. In addition, non-use areas had low willow component. So to get back to this active restoration site, this is how we designed it. This is what that looks like. That was a couple of months ago. That was in 2007. So these are very willow-dominated swales. This isn't all that we do. This is a small component of the landscape. We do other types of projects where we're putting in vegetation, and it's not all willows. So I wanted to point that out, that this may be not as indicative of what we're doing in the vast majority of the projects. So this is a vertical, excuse me, the vertical comparison and structure. And again, you'll see the active restoration site is a little bit different than all the others. But one of the things that I thought was interesting with high use and passive use, the non-use area is taller than both of those areas. It's a little bit difficult to see, but that really stands out when you look at the graphs in detail. By a couple of meters, 3 to 5 meters. So I think that's important too, and I'll talk about that in just a sec. So the volume was of course different in our active site. We had a lot of so this is canopy cover at different strata within the vertical architecture. So within our active sites, these are the willow swales. This is where all of the vegetative matter is. Passive restoration, high use, you can see it's spread out a little better. But here's a high use area. Not a lot at the bottom, or a whole bunch at the bottom, not a lot at the top. So that's sort of it's almost as if in some of our active restorations we're creating this non-use site. These are the things that I think are really important. I think Kathy really honed in on this at the end. The temperature variation, the only one that was really statistically different was in passive restoration, which I thought was funny because the other three are relatively the same. This line represents the average of all of them. The maximum daily temperature. So when she was doing these hobo comparisons, she was doing maximum, minimum, average daily variance, and then the average for all of them. And this was the only significant difference was in the, this is the active restoration site and the passive restoration site. So the daily temperature variation was different. The min and the max was different as well. And this plays out in a few other graphs too, where a lot of the variance is in the end of the season. It's not at the very beginning. Relative humidity, both the min and max were not statistically significant, but the daily variation was. And you can see this is pretty evenly spaced between, this is our active restoration and this is a passive restoration. This is the one that came up a couple of times before mine. This is the one that Kathy says is the most important. So here's high use and the rest of them are not statistically significant from each other. Kathy, time and time again, says if there's not water underneath that vegetation, then you're not going to get flycatchers. You can see that happened again. So this is soil moisture throughout the year, and this is early in the year. So she's really focused on the hydrograph in early getting precipitation or water in the river early in the year and having it stay for longer. These are recent hydrographs. They aren't indicative of the data that was collected, but she wanted to emphasize the fact that when this happens, she gets flycatchers. When this happens, she doesn't. So quick summary. How much time do I get? Oh, good. Now I'll get to the next part. So, like I said, I just wanted to throw all of that out so that you could see it, and we can talk about it later. You can come and, I have this on my laptop if you want to see these in more detail. You're welcome to come see me after the presentation. But this is really what she was keying in on. So in order to attract more males, sub-territories, encourage females, more water early in the season, and higher soil moisture retention throughout the breeding season is required. When I looked at the breadth of the data that she collected, there was like small differences sometimes in non-use and high use, and things that, oh, already? You said I was good. I'm not even close. Well, I got a few more actually. All right, let me race through the others, because this is important too. So she did the exact same thing in these areas in the Jemez where the leaf beetle ran through. I only have a few of these. She did paired studies. These are non-random selected sites. So she went through, and if you see control, these are normal bosky vegetation. Tamarisk is the site that had salt cedar, almost a monoculture, that then became defoliated. So this is why I wanted to show you this, is because the temperature in the control site, as everyone would expect, is going to be lower than if you defoliated all the leaf matter off of the tamarisk. This is also true later in the season, where this is where it became statistically significant. Here's relative humidity. Again, later in the season, it's statistically significant. Control had a better, the normal bosky vegetation had a better daily variation. And this is the last slide, so I'm okay. This is what, really what she wanted to point out. Defoliation occurred in some of the hottest months of the year, so it was the worst time for it to happen. The daily temperature and the relative humidity was more extreme when the foliage is removed. That's what we would expect. It just happened to happen at the worst time possible. This process should be seen. This is my own point of view. I did this because I want people to think about these parameters when we go through restoration. If we eliminate all the salt cedar, it's not that much different than if a beetle went through and eliminated all the vegetation off of the salt cedar. I'm not saying that we shouldn't be removing salt cedar, but we should understand the effects that we have when we do that. So if we go tearing through these areas, and I'm going to do it this year, this is what we should expect. So we have to understand how to mitigate for that. And that's all I have.